Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Done the formula in the first part of this lesson. Therefore, we'll go ahead with the numerical sums. Question 1. The position versus time for a certain particle moving along the x-axis is shown in the figure. Find the average velocity in time interval. A is equal to A 0 to 2 seconds, B 0 to 4 seconds, C 0 to 4 seconds, 2 to 4 seconds, D 4 seconds to 7 seconds, and E 0 to 8 seconds. For A, the average velocity will be displacement upon time, and we can write 10 meter upon 2 seconds, that is 5 meter per second. For B, the same formula, we can write average velocity is equal to 5 meter upon 4 seconds, that is 1.2 meter per second. C, same formula, average velocity is equal to displacement upon time, 5 meter minus 10 meter upon 4 seconds minus 2 seconds, that is minus 2.5 meter per second. D, same formula, displacement is equal to x2 minus x1 upon t2 minus t1, that is minus 5 meter upon 7 seconds minus 4 seconds, that is minus 10 meter upon 3 seconds, that is minus 3.3 meter per second. E, same formula, average velocity is equal to x2 minus x1 upon t2 minus t1, 0 minus 0 upon 8 minus 0, that is 0 meter per second. Question 2. Particle moves according to the equation x is equal to 10t squared, where x is in meter and t is in seconds. A. Find the average velocity for the time interval from 2 seconds to 3 seconds. B. Find the average velocity for the time interval from 2 seconds to 2.1 seconds. So our equation is x is equal to 10t squared. We'll put the different values of time. We'll get distance value accordingly. Now A, average velocity is equal to displacement upon time, that is 50 meter upon 1 second, that is 50 meter per second. B, same formula, average velocity is equal to displacement upon time, that is 4.1 meter upon 0.1 second, that is 41 meter per second. Question 3. In 1992, world speed record by a bicycle was set by Chris Huber. His time was measured 200 meter stretch was in sizzling 6.509 seconds. In 2001, Sam Whittingham beat Huber's record by 19 km per hour. What was Whittingham's time through the 200 meter? Hoover's speed V0 is equal to 200 meter upon the time taken was 6.509 seconds, that is equal to 30.72 meter per second, which is equal to 110.6 kilometer per hour. Where we have used the conversion factor 1 meter per second is equal to 3.6 kilometer per hour. Since Whittingham beat Hoover by 19 kilometer per hour, his speed is V1 is equal to 110.6 km per hour plus 19 km per hour, that is 129.6 km per hour, or 36 meter per second. Thus, using the equation of motion, we can get delta t is equal to delta x upon v1, that is 200 meter upon 36 meter per second, that is 5.554 seconds. Question number 4. An automobile travels on a straight road for 40 km at 30 km per hour. It then continues till the same direction for another 40 km at 60 km per hour. What is the average velocity of the car during the full 80 km trip? It moves in the positive x direction or x-axis. B. What is the average speed? C. Graph x versus t and indicate how the average velocity is found on the graph. So we know that average velocity is equal to delta x upon delta t. A. During the first part of the motion, the displacement is delta x1 is equal to 40 km and the time interval is t1 is equal to 40 km upon 30 km per hour, which is equal to 1.33 hours. Similarly, during the second part of displacement is delta x2 is equal to 40 km and the time interval is t2 is equal to 40 km upon 160 km per hour, which is equal to 0.67 hour. The total displacement is delta x is equal to delta x1 plus delta x2 is equal to 40 km plus 40 km, which is equal to 80 km, and the total time is equal to delta t1 plus delta t2, which is equal to 2 hours. Consequently, the average velocity is V average is equal to displacement upon time, that is 80 km upon 2 hours, that is 40 km per hour. In this case, the average speed is same as the magnitude of the average velocity is equal to 40 km per hour. C. The graph of the entire trip is shown below. It consists of two contiguous line segments, the first having a slope of 30 km per hour and connecting to the origin to delta t1 and delta x1 is equal to 1.33 hour 40 km, and the second having slope of 60 km per hour and connecting to delta t1 delta x1 to delta t delta x is equal to 2 hours and 80 kilometers. Question 5. Starting from a pillar, you can run 200 meter east the plus x direction. at an average speed of 5 meter per second and then run 280 meter west at a speed of 4 meter per second to a post. Calculate your average speed from pillar to post and your average velocity from pillar to post. Average velocity is equal to displacement upon time. Therefore, solution for A will be the eastward run takes time is equal to 200 meter upon 5 meter per second, which is equal to 40 seconds. The westward run takes time is equal to 280 meter upon 4 meter per second, that is 70 seconds. The average speed of the entire trip is equal to 480 meter upon 110 seconds, that is 4.4 meter per second. B. Again, average velocity is equal to delta x upon delta t is equal to minus 80 meter upon 110 seconds, that is minus 0.73 meter per second. The average velocity is directed westward. A stone is dropped from a height of A stone is dropped from a height of 19.6 meter above the ground while a second stone is simultaneously projected from the ground and with sufficient velocity to enable it to ascend 19.6 meter when and where the stone would meet. Let the stone meet at height s meter from the earth after t seconds. Distance covered by the first stone h minus x is equal to half gt square, where h is equal to 19.6 meter. From the second stone, for the second stone, s is equal to ut is equal to half gt square, b square is equal to 0 is equal to u square minus 2gh. Therefore, u is equal to 2 under root 2gh. u is equal to under root 2gh is equal to if we put the values, it will give 19.6 meter per second. Adding equation 1 and 2, h is equal to ut, t is equal to h upon u, 19.6 upon 19.6 is equal to 1 second. From equation 2, if we put these values, we will get 14.7 meter. Question 7. A particle moves according to the law x is equal to sine pi t, where x is the displacement and t is the time. Find the distance traveled by the particle. X is equal to a sine pi t is equal to a sine w t, where omega is the angular velocity, w is equal to pi. The time period t is equal to 2 pi by w. Omega is equal to 2 pi by pi is equal to 2 seconds. In half second, a quarter of the cycle, the distance covered is a. Therefore, in 3 seconds, distance will be covered by is equal to 6a.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.